Good morning all. We, the Department of Chemistry, welcome each one of you to the International Virtual Conference on Nanomaterials, Recent Developments and New Directions, organized in association with IQAC, Bishop Kuryalashiri College for Women, in collaboration with Cape Comorin Trust, India, and Cape Comorin Publisher, India. I, Annu Joseph, take this opportunity to share a brief introduction about BK College Amalagiri and the Cape Comorin Trust. Bishop Kuryalashiri College for Women is named after Venerable Mar Thomas Kuryalashiri, a visionary who championed the cause of education and empowerment of women. This center of learning was founded by the Sisters of the Adoration of the Blessed Sacrament in 1965 with the noble goal of shaping young women into empowered citizens through value-based education. The college, which opened the vistas of higher education to women now, distinguishes itself as the institution in the vanguard of women's education in the nation. Our key principle is the belief that by educating women, we educate a whole generation. The college is a government-aided college and is affiliated to Mahatma Gandhi University, Kottayam. We scored A+ grade in the 4th cycle of NAAC assessment process in 2019 and 89th position in the NIRF. The Department of Chemistry, established in the year 1965, offers undergraduate and postgraduate programs and possesses outstanding facilities which provide an exceptional environment for the student to learn and pursue a career in chemistry. As part of keeping our motto, search the truth and reach the truth alive, we are extremely delighted to collaborate with Cape Comorin Trust, the trust which symbolizes humanitarianism. The trust was formed with the aim of education and charity. The purpose of Cape Comorin Club is to organize programs to promote academic activities throughout the world. And thus, as a result of this objective, here we are at the International Virtual Conference on Nanomaterials, Recent Developments and New Directions. I hope that this conference gives all of us a chance to learn and advance our knowledge about the recent trends on the field of nanochemistry. Hope you will have a good time. Hearty welcome to the inaugural ceremony. To grace this virtual conference, let's seek the blessings of God Almighty. Prayer song.
In His time, He make all things beautiful in His time. Lord, please show me every day as you teaching me your way, that you do just what you say in your time, in your time, in your time. You make all things beautiful in your time. Lord, my life to you I bring, with its winter and its spring. May I fathom everything in your time, in your time, in your time.
I invite Sister Aji Joseph, Head of the Department of Chemistry, BK College, Amalagiri, to welcome the gathering.
Am I audible?
Yes, sister, you're audible.
A very good morning to one and all present here. Dr. Lena Matthew, Principal, BK College, Reverend Sister Lily Rose, our Administrator, Dr. R.S. Regine Sylvester, President, Cape Comorin Trust, distinguished speakers of the day, Dr. Seif Ali Chaudhary, Professor, Department of Chemistry, Jamia Millia Islamia, New Delhi, Dr. Gurpreet Kaur, Assistant Professor, Department of Chemistry, Government College for Women, Jammu and Kashmir, Dr. Jinida Vogis, IQAC Coordinator, esteemed guests, members of Cape Comorin Trust, delegates, teachers, and dear students. I'm before you this auspicious morning with a grateful heart. Though we are in the midst of COVID pandemic, today we all have gathered here to discuss about a very relevant topic, nanomaterials, recent developments and new directions. Nanoscience breaks through in almost every field of science, and nanotechnologies make life easier in this era. Nanotechnology and nanoscience represent an expanding research area which involves structures, devices, and systems with novel properties and functions due to the arrangement of their atoms on the 1 to 100 nanometer scales. Nanotechnology contributes to almost every field of science, including physics, material science, chemistry, biology, computer science, and engineering. Notably, in recent years, nanotechnology has been applied to human health with promising results, especially in the field of cancer therapy. We should distinguish between nanoscience and nanotechnology. Nanoscience is a convergence of physics, material science, and biology, which deals with manipulation of materials at atomic and molecular scales, while nanotechnology is the ability to observe, measure, manipulate, assemble, control, and manufacture matter at the nanometer scale. We all know that the concept of nanotechnology was introduced in 1959 by the American physicist and Nobel Prize laureate Richard Feynman in his lecture entitled "There is Plenty of Room at the Bottom." Feynman made this hypothesis: why can't we write the entire 24 volumes of the Encyclopedia Britannica on the head of pin? And described a vision of using machinery to construct small machines and down to the molecular level. We can see the use and development of nanomaterials, the 4th century AD, Lycurgus, 9th century glowing, lustering ceramic, 13th century Damascus saber blades, 18th century Michael Faraday's ruby, 19th century devices, SEM, TEM, XPS, STM, and AFM, 20th century carbon dots, carbon nanotubes, fullerenes, etc. Recently, a number of studies highlighted the huge potential that now nanotechnology play in medicine for the diagnosis and therapy of many human diseases. Against this backdrop, we have assembled here to know more about the topic with eminent personalities. Let me get into the pleasant task of welcoming you all this happy occasion. Our principal, Dr. Lena Matthew, is the president of this inaugural session. We owe much to you and for your grateful presence. It's her vision and inspiring support that fills us with strength and sense of purpose. Dear Mom, on behalf of everyone, and especially the Department of Chemistry, I welcome you cordially to this function.
Thank you.
I am happy to welcome our administrator, Reverend Sister Lily Rose, to this gathering. I acknowledge her encouragement on all occasions we needed it. On behalf of all present here, I welcome you heartily, Sister. It's my honor to welcome Dr. R.S. Regine Sylvester, President of Cape Comorin Trust, whose generosity and support made this conference a reality. With a grateful heart, I welcome you, dear sir. And I am happy that this occasion is graced by Dr. Seif Ali Chaudhary and Dr. Gurpreet Kaur, the big wheels of the day. On behalf of all gathered here, I extend to you both hearty welcome. Dr. Jinita Verghese, IQAC Coordinator of VK College, is a source of strength and support. Dear Miss, I extend to you an affectionate welcome. The conference will be just a success based on the enthusiasm and interest of the participating team. I welcome our participants from all across the country who responded to our invitation. May you find this an inspiring experience. My dear colleagues in the department, especially Dr. Ashais Matthew, Ms. Maria Jacob, Dr. Daisy Joseph, Roshni, Needu, Anu, Sharni, and Anita, and all teachers from our college help us make this dream a concrete and fruitful reality. Cordial welcome to you, dear teachers. Last but not least, my dear students, it's for you this event is organized. A loving welcome to each and every one of you. A lot happened from a powerful word of Richard Feynman. Now, I wish all of you that this international conference and the words, the visions, and the ideas shared in this platform motivate people to action and become a catalyst that lead to changed thinking in the mind and share hope to the heart of the listener. I welcome you all once again to the seminar and hope that you all will have a great time ahead. Thank you. Thank you so much.
Thank you, sister. I also welcome you, sister, our pillar of support to this function. With great pleasure, I invite Dr. Lena Matthew, our principal, for the inaugural address.
Good morning, everybody. The International Virtual Conference on Nanomaterials, Recent Developments and New Directions, organized by the Department of Chemistry in association with IQAC and in collaboration with Cape Comorin Trust India and Cape Comorin Publisher India, is a wonderful initiative taken. It is indeed an honor for me to speak a few words on the occasion of the inaugural session of this international webinar on nanomaterials, recent developments and new directions. As we know, nanomaterials are of much relevance in the science of chemistry, and recent developments in this field are a must to be analyzed for the faster growth of the economy. The recent findings in this area will give new directions in this field of research. Dr. Ari Sylvester, the president, is much appreciated and acknowledged to give us a venue for this international webinar. The keynote speaker of the session is Dr. Seif Ali Chaudhary, Professor, Department of Chemistry, Jamia Millia Islamia, New Delhi. Our plenary speaker is Dr. Gurpreet Kaur, who is Assistant Professor of Chemistry, Government College for Women, Jammu and Kashmir. And I think that this is a wonderful forum for our dear students to interact and to know more about the subject. As we know, nanomaterials can have different physical and chemical properties to their bulk form counterparts. In the health field, for example, the nanomaterials are utilized in a variety of ways, with one major use being drug delivery. The use of nanomaterials are prevalent in a wide range of industries and consumer products like cosmetic industry, sports industry, and even military. The Department of Chemistry of BK College has taken much initiative to organize this program. I congratulate the department headed by Sister Aji Joseph for taking this initiative. The Cape Comorin Trust India and Cape Comorin Publisher India has been very kind to collaborate with BK College for the second time in the form of an international virtual conference. Our appreciation and gratitude to the Cape Comorin Trust India and Cape Comorin Publisher India is of specific mention. On behalf of the management, the staff, and students of BK College, I express our sincere gratitude. Wishing the virtual conference all success, and I hereby declare the conference as inaugurated. Thank you one and all.
Thank you so much, ma'am, for the encouragement and support you render. May I now request the administrator of our college, Reverend Sister Lily Rose SABS, to offer the felicitation.
Good morning, everybody. The International Virtual Conference on Nanomaterials, Recent Developments and New Directions, organized by the Department of Chemistry, is an event of great importance as nanomaterials are changing dramatically our lives in various ways. Nanotechnology takes inputs from all the science fields of engineering, physics, chemistry, biology, and material science and places them together and make everything run at the quantum level or nanoscale level, a billionth of a meter. The highlights of the talk is to be covered in this event will focus on in the development of nanomaterials and their applications. I am sure this conference will provide the latest overview of this field. The Department of Chemistry always shows keen interest to offer various opportunities for students to interact with eminent resource persons. I take this opportunity to appreciate the MTech team, Institute of Chemistry, editors, other organized committee members in arranging this international conference with eminent speakers. I wish the esteemed speakers of the day and all the participants inspiring scientific interaction. Have a good day. Thank you all.
Thank you, sir. Now, Ginitha Verghese, IQAC Coordinator, BK College, Amalagiri, felicitation.
Good morning to all.
Yes, ma'am.
Distinguished dignitaries, delegates, colleagues, and my dear students. I'm really happy and proud that the Department of Chemistry, Bishop Kuryalasheri College for Women, Amalagiri, is organizing an international virtual conference on nanomaterials, recent developments, and new directions in collaboration with Cape Comorin Trust and Cape Comorin Publisher, and also in association with Internal Quality Assurance Cell of BK College. The topic of this webinar is of high relevance in the current global scenario. We all know that nanomaterials are cornerstones of nanoscience and nanotechnology. Nanostructure science and technology is a broad and interdisciplinary area of research and development activity that has been growing explosively worldwide in the past few years. It is already having a significant commercial impact, which will surely increase in future. Hence, I congratulate the coordinators, the Department of Chemistry, for selecting this particular topic. I also thank the office bearers of Cape Comorin Trust and Cape Comorin Publisher for collaborating with BK College for organizing this wonderful international conference. An event of this magnitude becomes a success only when each of us puts in our best. Let us resolve to do the utmost and make the best of this academic endeavor. I wish all of you a stimulating academic experience in this virtual platform. Thank you.
Before moving to the core of today's conference, I would like to thank our principal, Dr. Lena Matthew, our administrator, Reverend Sister Lily Rose, SABS, and IQAC coordinator, Dr. Ginitha Verghese, for sparing their valuable time and being with us. Thank you. We are honored to have with us our respected speakers of today's conference, Dr. Seif Ali Chaudhary for the keynote address and Dr. Gurpreet Kaur for the plenary session. I invite Ms. Roshni Roy, faculty member of the Department of Chemistry, to introduce our keynote speaker, Dr. Seif Ali Chaudhary.
Good morning, everyone. It's my great pleasure to welcome Dr. Seif Ali Chaudhary, Professor, Department of Chemistry, Jamia Millia Islamia, New Delhi. He is an authoritative person in the field of inorganic chemistry. His research area is in environmental chemistry, nanotechnology for water treatment. He has many administrative experiences. He is a member of committee for the preparation of university's policy document for startups and entrepreneurship, assistant proctor, CBCS core advisor, MSc Chemistry, Jamia Millia Islamia, New Delhi, assistant superintendent for university entrance test for engineering for several times, and so on. He has got several publications credited to national and international journals. He has many PhD students under guidance. On the behalf of the Department of Chemistry and IQAC BK College Amalgiri, I cordially welcome you, sir, for the keynote address. Thank you.
Hello. Am I audible?
Yes, sir. Yes.
Good morning, Dr. Roshni, for very good words about me. I would like to thank Dr. Lena Matthew, Principal of BK College, Sister Lily Rose, Administrator of the college, Sister Raji Joseph, HOD Department of Chemistry, BK College, for inviting me to this international virtual conference on nanomaterials, recent developments, and new directions. The topic chosen for today's keynote address is related to the nanotechnology field. This is something related to my research area. What we are doing in Department of Chemistry, Jamia Millia Islamia, is preparation of nano composites for the water treatment. Now, I'm sorry. Yes. My research area is use of nanocomposites for water treatment. Now, actually, what is water pollution? This is a very burning issue, and it has been left as such. But this pandemic situations caused by the COVID-19 has created a havoc that a virus, very tiny particle, can destroy the whole economy and world has still, and because of the properties associated with it. Now, water is equally important. If you think of water pollution, it is a addition of any harmful substance, maybe chemicals, maybe microorganisms, which add to stream, river, lake, ocean, aquifer, or other water bodies to degrade water quality and ultimately making water toxic and unfit for human consumption. Am I audible, please? Hello?
Yes, sir.
Hello?
Yes.
Oh,
Yes, sir.
am I audible?
Yes, sir.
Yeah.
Yes, sir, you're audible.
Okay, thank you very much. So let me have, for introduction, just we have how many types of pollutants. Organic pollutants includes dyes, insecticides and herbicides, pesticides. In common we call detergents. You use a lot of detergents, and ultimately the waste detergent is added to the water. Pharmaceutical drugs, etc. You are using and wasting and ultimately leading to the consumption by this water. Solvents we use in industry for multiple purposes, and chlorinated solvents are a severe class of solvents which add to the water. Inorganic pollutants include heavy metals released from industries, etc., and we have, for my own purpose, included arsenic in heavy metals, although it is not heavy metal, but it has been included just for making it simple. Acid and bases or alkalis we use lot in industry and ultimately reaches to the water, causing water pollution. Industrial discharge is a common. Now, inorganic pollutants, this is related to my research area. Heavy metals, they are very toxic to the human body, and not only human body, to the other animals which survive in water. And this left hand side image taken from the net is showing from where these heavy metal ions are added to the water bodies. Industrial waste is one of the major component which add heavy metals into water bodies. Urban waste, mining, mining is also mining, have done to extract the metal ions, and if not done properly without any precautions, they add to the water, causing pollution. Agriculture activities like zinc sulfate is used, and that ultimately lead to heavy metal pollution. And what is the problem actually with these heavy metals has been shown at the right side of this presentation. It is a bioaccumulation of methyl mercury. Methyl mercury means the source of mercury. Mercury is a very toxic metal ion, and it ultimately reaches to this fish, and fish is eaten by human body and reaches to the human body. Just this red spot is showing the accumulation of mercury in kidney or adjoining areas. Again, the whole body ultimately leads to contamination. Now, dyes, these dyes are very beautiful otherwise, and I'm just wearing this blue color shirt, and you all might be using colored clothes, and it this colors add to the beauty to the clothes, but ultimately the process needs lot of dyes, and this extra dyes or waste has been discharged into the river. Here it is a Ganga river near Kanpur, and the process is indicating the severity of the problem. Now, dye pollution causes aesthetic quality of water is devastated, and when the dye is present in water, it prevents the penetration of sunlight. If sunlight is prevented, then the other photochemical reactions which takes place in the aquatic environment are stopped. Dyes are organic compounds. They reduce dissolved oxygen in water, and if a reduced dissolved oxygen is there, then it ultimately leads to the death of the aquatic animals like fish and other. And most of the dyes, synthetic dyes, they are toxic and carcinogenic. 1.5 million tons, this is the big amount, 1.5 million ton of dye is released into water bodies through wastewater from industries. Now, microbial pollution. Microbes, usually bacteria, are present in such water bodies which cause various chronic and acute diseases. Annually, about 2 million people dies because of this microbial pollution. Therefore, we should have a material which can remove both organic, inorganic, and microbial pollutants from the water to make it suitable for human consumption. This is our purpose. Now, this arsenic needs special attention because this is very notorious element, and whole world is almost suffering because of it. The red spot shown here at the left side is USA, and this coastal area, it is around also including Canadian part, and then we have South America. We have arsenic presence beyond the uh, concentration which is permissible as per the WHO regulations. Now here we have Bangladesh, China, etc. And Bangladesh and adjoining Indian state West Bengal is the worst hit area. It is most affected area. Now let me see uh, our own country. It is West Bengal, which is most affected area. But other states like Uttar Pradesh, the biggest population wise, having 20 more than 20 crore people residing in the country. It is more than population wise bigger than even combination of England and France. So this huge population is under the attack of arsenic poisoning. Bihar is the next state. Again, Assam, we have lot of arsenic in water in Assam and Karnataka, your sister state, adjoining state. The red portion is indicating the presence of arsenic in water more than permissible limit. Now, in West Bengal, you look at this, the approximately more than 60% of the total area and might be population also is under the attack of arsenic poisoning. This arsenic poisoning is more problematic because of the social economic conditions. These are the images I have taken from the internet showing the life in Bangladesh during the flood situations. Now, the whole water contains arsenic, and left side you just see the cultivation of paddy crop by arsenic contaminated water causes arsenic poisoning also through rice. Rice have been detected with more arsenic, therefore it is not fit for human consumption also. These are the images I have taken from the internet also, where we have the effect of arsenic. Arsenic ultimately is carcinogenic and it causes cancer, and it retards the photosynthetic activity. It inhibits the growth of aquatic biota, mutagenic, catogenic. These all are the effect. And here I have tried to show you the body parts where the arsenic effect is more severe. That the liver, very important part of the body, is affected. In fact, what happens, arsenic get accumulated in the soft tissues like kidney, uh, the lungs, etc., causing diseases. And these also, arsenic presence also cause diabetes. It also cause impairment of mental activities, skin cancer, dermal diseases, lesions and pigmentations. These are the heart attack is also associated with the arsenic poisoning. How arsenic gets dissolved in water? That is because of the natural phenomenon. Arsenic containing compounds get dissolved in groundwater as well as in the aquifer, and this due to the passage of time, the concentration of arsenic is increasing, and the poverty around this West Bengal and Bangladesh is adding to the problem. No, actually, how this arsenic affect the human body? Just look at the right side of this Yeah, this is a molecule, and when the phosphate is given to this molecule, it converts into 1,3-diphosphoglycerate, which ultimately leads to the formation of ATP, means the energy to our body. And but when instead of phosphate we have arsenic compounds, it leads to 1-arsino-3-phosphoglycerate, which ultimately lead to the stoppage of ATP formation. And when the energy is not there, lot of problems start operating in the body. How we can prevent this? What is the antidote, or what are the remedies we can use? We can remove this arsenic from uh, this protein part. Protein, it get attached to the protein, forming arsenide chelate on the enzyme surface, protein or simply enzymes, right? But when this uh, uh, 1 2 this is 2,3 dimercaptopropanol is given to it, this detach the arsenic group from the enzymes, and therefore the enzyme is freely available now for the for its own function. But ultimately you think this big population around uh, population in crores, is it possible that you are just removing arsenic from the body? Not, it cannot be. We know this situations, and India is celebrating that we have uh, given 100 crore doses of the vaccine, COVID vaccine, but such type of treatment cannot be given to all the persons on daily basis. Therefore, there is no solution at all. And what are the solutions? Actually, we have to move to the history. Around 4000 BC or 6000 year back, ancient Greek and Indians were treating water through charcoal filtration, sunlight exposure, and boiling, just to improve the taste and odor. 6000 years back. And around 1500 BC, ancient Egyptians used chemical alum to cause suspended particle to settle in the water, making it free from suspended particles. Filtration was started during 17. This is a recent phenomena. Or in 18th century, the effect of drinking water contaminants on the human body was identified. The cholera was chart uh, treating. Then during the 19th century, discovery of the filtration to remove the turbidity was operated. Right during the 1960s, advancement in industrial and agriculture sector led to the identification of man-made chemicals like pesticides, organic chemicals, pharmaceutical, heavy metals, etc. in the water. This is a historical perspective which indicates that the filtration of water is not a new phenomenon. It was there. Now we have how many techniques available for water treatment? Precipitation, flotation, ion exchange, electrocoagulation, adsorption. In all these, adsorption is supposed to be the most efficient and economical as well as eco-friendly technique. Although this adsorption process was there around us forever, but only around 40 to 50 years back, its commercial application was came into uh, the mind of the scientist. And the process of adsorption has been commercialized by using some materials like activated carbons, activated alumina, silica gels, and aluminosilicates. These are the compounds which led to the commercialization of this adsorption phenomenon. Nowadays, we know this adsorption has been occurring in many natural phenomena. Physical adsorption, biological activities, chemical systems, they are there because of the adsorption. Now, this uh, virus is also moving from one person to other person through adsorption. And the latest research is based on the nanotechnology. Why nanotechnology? Because adsorption is a surface phenomena, and the smaller particles, they have more surface area, and at the same time, this uh, nanoparticles, they have more number of atoms at the surface in comparison to the bulk material. Therefore, the nanomaterials are more efficient as compared to the normal bulk material for the adsorption phenomena. Now, why adsorption? It should be sustainable. Sustainable means the source or the material you are using should be available in plenty. And uh, there is a historical perspective that adsorption started with the organic materials like plant-based materials, and we have followed the same principle here, and we have used acid washed black cumin seeds as a adsorbent, and the paper has been published in a reputed journal of molecular liquids. Now, recent advancement and our advancement also is preparation or synthesis of the composite, or simply nanocomposites. We have number of nanocomposites, and but we have plant material based composites which are sustainable because of the availability of plant material. Yes. The advantage with these material is introduction of a specific property as per our requirement. Now, the nanomaterials can be made uh, magnetic also. Because of the smaller size, they can be magnetic. The nanomaterial separation is required after the absorption process, but the separation of very small particles like nanoparticle is very difficult, and they needs highly sophisticated instrumentation. Hello, audience, please. Am I visible? Because light is not available. Hello.
Okay, sir, you're visible. So,
Am I visible? No.
yeah.
Oh. Then this we have tried to make the composite magnetic through nano magnetic component in the composite material. Yeah, more advantages there, that these hybrid composites, organic and inorganic part, both combined together to form this nano hybrid composite. They ultimately changes the band gap. Semiconductor type materials can be this band gap, energy gap between conduction band and the valence band can be altered through this combination of organic part. Now, this look at this arsenic 3. It is arsenic exists only in two forms, arsenic 3 and arsenic 5. Arsenic 3 is more toxic, or it is 50 to 60 times more toxic than arsenic 5. And arsenic 3 can be oxidized to arsenic 5 uh, through oxidation, and that oxidation can take place through this hybrid composite material. Arsenic 5 have the more adsorption capacity, as compared to the arsenic 3. Therefore, this material can be prepared as per our requirement of oxidation of arsenic 3 to arsenic 5. Now, a lot of papers are available in the literature where you can see that carbons have been prepared from the organic material like plant-based materials, and they have been used as adsorbent, as we have also done. But such organic materials uh, cannot be used for long time because of presence or because of generation possibility of generation of bacteria or any organic organism in it. But when the same material has been used as a composite, and then it becomes safe because the bacteria or microbes cannot survive on uh, such nanocomposites. These nanoparticles, they have effect to control the growth of bacteria. Therefore, our purpose was just to make carbon-based hybrid nanocomposite for making it more suitable. Now, we have chosen black cumin seed. Black cumin seed. Why black cumin seed? Because these black cumin seeds, they are being used in every household, and they are safe as compared to other materials. They are safe used as ingredients, cause supposed to be cause no effect, adverse effect on the human body. Moreover, they have therapeutic applications also. uh, it, in Quran also it is there that these black cumin seeds, they have remedies for so many diseases, and historically and through experiment it has been proved. Now, how the composite was prepared? This is manganese oxide was combined to black cumin. BC stands for black cumin. Now, this schematic representation has been given over here, and we got the publication in the environmental research. Look at this. This is a dye we have taken, and after treatment, we have got the pure water without any contamination. That's and the material MnO2 is a semiconductor type. Therefore, it has also shown photo degradation capability, and it has also shown this antibacterial activity against gram negative. Therefore, the single composite was capable to clean water through controlling bacteria as well as removal of dyes, and this antibacterial this photo through adsorption as well as through the photo degradation techniques. Now, preparation. So now, for preparation part, this black cumin or other compound, other organic materials, plant-based materials, they have number of functional groups at their site. Here we have shown that OH is one of the group, and sometimes it is O negative, shown O negative, and other times it is COO negative, means acidic group, and sometimes maybe amide, but we have just ignored that. And now this manganese source MnCl2 was taken and it was oxidized using KMnO4, potassium permanganate solution, and it led to the formation of techniques. Now here, what is 3360 centimeter inverse indicates the presence of OH. Hydrogen bonding are 2920 and 2850. Peaks corresponding to methyl and methane groups in the black means molecules. These are the other peaks corresponding to various functional groups. CO functional group means keto group is also there, and this is a manganese dioxide uh, IR. It indicates it is having again 3430. Again, it is because of the presence of hydroxyl groups on the surface of manganese dioxide, and we have characteristics peaks around 565 and 480 nanometers, indicating manganese and oxygen vibrational frequencies. Now, this composite here it is 3360 to 3330. It means there is a reduction of 30 centimeter inverse in the frequency of hydroxyl group, indicating that some of the hydroxyl groups have bonded to say this magnesium dioxide. So through hydrogen bonding, in this way we can establish the formation of composites. Now in composites, in black cumin seeds, these peaks were absent, but in MnO2 these peaks were there, and after combination with the black cumin, the peak values have slightly changed, like from 565 it has become 511. So it indicates interaction of manganese with other groups, and again 480 has been reduced to 459, again because of these interactions with the black cumin. That indicates that a composite has been formed. Now when it was used as adsorbent, this composite, then we got broadening of this peak because of then 3319, slight change, because this OH group present on the surface of the composite has been interacted to MB, methylene blue molecules. That indicates the interaction of composite with methylene blue or any other dye, right? Now XRD technology was used to find the size. Scherer formula was used to find the size of the particle, which came to 59.11 59.11 nanometer. That indicates the size of the particle. Right? The SEM, scanning electron microscopy, was used to study the morphology or the surface structure, and then these TEM technology, tunneling electron microscope, was used to measure the size of the particles. Then EDX was used to know the elemental composition of the composite. That is, carbon was there, nitrogen was there, oxygen was there in the pure black cumin. But after the composite formation, manganese got appeared, indicating the presence of manganese on the surface of, and unfortunately there appeared one peak corresponding to potassium, because potassium we have used KMnO4, and that potassium from the KMnO4 get trapped into the crystal. Now the material Nano composite was characterized through the TGA thermogram, and it indicates that during 100 to 200 degrees Celsius temperature, evaporation was there. Evaporations means water evaporations, and the volatile organic compounds available in the black cumin was evaporated. during this. Now around 460 onward, it was pyrolysis. Pyrolysis means and only the 56% of the total weight got lost. It means only 44% was oxide component. Oxides, they are very stable, therefore they were there, and 56% of the organic material has gone away. Now, once the uh, composite was established, we tried to know the surface charge, and at the neutral conditions it was 6.75. It means the ZPC 0 point charge, it was 6.75. At this it is neutral, but after this it is a negatively charged surface, and before that it is a positively charged surface. Therefore the material can be a very effective around 6.75, right? Now the for the application of this compound on the real problem, what we need to optimize the dose, how much amount of the compound is required, that is found through the plot between absorption percentage and dose of the adsorbent. Now, so in this way we can optimize the dose. Now, the second thing to optimize is time, and this is the plot shown here. Just plot between adsorption percentage and time. And initially we started with 15-minute duration, and it reached to 45 minutes. So 45 minutes is sufficient time for the cleaning of around 97 point or 98% of the dye within blue we have taken can be cleaned uh, within 45 minutes. So this time is a very good duration. It is not so long time, therefore we can apply this material on commercial scale also. And this is something which is required. The concentration optimization, dose is optimized, time is optimized. Now the concentration, how much concentration we can. So this adsorption decrease with concentration, and around 20 ppm concentration, this was almost constant. This although is showing a steep curve, but the percentage you look at, it is 97 and around 98. So this the percentage is very small. The variation is very small, only 2%, 97 to 98, or rather 1% only. So therefore, you can clean the methane blue having solution having concentration up to 35 and 15 ppm within 45 minutes, having dose 1.5 gram. So this is now the effect of pH is important. You know this when you have to apply the technology on real situations, and water or the wastewater coming from an industry, the industry they use lot of acids and bases, and ultimately pH of the water is altered, and we must know how effective is change of pH on your system adsorption. Now this was a ZPC 0 point charge, it was around 6.6 and 7. Therefore after 6 or 7 or nearby 6 7 or other neutral condition, the material was very good or it was effective. Now other parameters we need to know is this Gibbs free energy change, and this is the plot between B in the logarithmic term and temperature, and we have got delta G that indicates negative 0.86 something. It is always negative here, at 3 temperature we have studied 27, 35 and 45 degree, indicating that the process of absorption was better at high temperature 45 degrees Celsius temperature, and delta H was exothermic and there was evolution. These are parameters are required for the uh, proposal of mechanism. Actually, this is the Langmuir isotherms. Prandtlish isotherms have been applied, Temkin isotherm and Dubinin isotherms, and these isotherms give us these parameters. This Q naught value is important. It is 84 at 27 degree, 30 at 35 degrees Celsius it is 106, and at 45 degree it is 185. This indicates that the absorption capacity of the material increased with increasing temperature. So therefore, this 185.185 is a very good number. Therefore, the material was good in sense. And these other parameters like Dubinin, Radoshkevich isotherm depict this EDR 2.69, 2.17 and 1.949, indicating that the process was of physical nature. The absorption process was of physical nature, and it should be actually physical absorption. Otherwise, if it is chemical absorption, the material cannot be used in a cyclic way, but it was a physical absorption. Therefore, the material can be used after washing for consecutive cycles. Now, it is again important for the system to operate in a commercial level to know how much is the speed. Then what type of kinetics it is following, and we have done pseudo first order kinetics, we have done pseudo second order kinetics. Ilovich model is there also, and intraparticle diffusion and this film diffusion. These are the parameters which we need, and from these we establish that this uh, uh, system was following the pseudo second order, means both the amount of the adsorbent and the uh, concentration of the solution or the concentration of the pollutant determine the utility of the materials. Therefore, this gives an idea that you can increase or decrease the adsorption by altering the amount of adsorbent or changing the concentration of the solutions. The mechanism we have proposed, look at this. Magnesium dioxide is having OH ions, OH hydroxyl group present on the surface. They interact with nitrogen through hydrogen bonding. This methylene blue is a molecule where nitrogen is there, and there is a hydrogen bonding between oxygen and nitrogen through hydrogen atom, right? Here again we have, and one electrostatic interactions can be there. This nitrogen is having positive charge, it interacts to the magnesium dioxide, and the materials they have advantages. Composites are better than the uh, simple nanoparticles. Why? Because these in our case black cumin is having so many functional groups. They also interact with these dye molecules. Therefore, the amount uh, therefore the adsorption capacity of magnesium oxide has been now enhanced in comparison to these simple magnesium oxide, because this black cumin or other organic part can also interact to these dyes, metalloids or arsenic. Now, the composite was also used for photodegradation of the dye molecules. And we started with 5 minutes, 15 minutes, 30 minutes, 45 minutes, 60, and up to 120. You see here at this absorbance was maximum. Therefore, the concentration of dye was maximum at 5 minutes, but it reached to the minimum value at 120 minutes. So therefore, 120 minutes was sufficient time for the photocatalytic degradation of dimethylene blue from the solution. Now we have also studied the effect of temperature on the dye photodegradation, and this degradation percentage has been more at 45 degrees Celsius. That may be because of the excitation needs more energy, and at higher temperature this much energy is made available. Now the mechanism has been proved. You know, these electrons are available on the methylene this black cumin surface, and they get excited to the higher conduction band and creating positive hole here, and this water interact in between and undergoes oxidation, creating OH. This OH directly attack this methylene blue molecules, leading to its degradation. Again, O2 is also there, and that get oxidized, reduced to O2 negative, and ultimately to OH free radical, leading to attack of this OH free radical on these dye molecules and ultimately degrade the methylene blue dye in this case. Now this is the study we have done, how to control the bacteria E. coli and S. aureus. Both these are the uh, positive and negative bacterial stains which we used for our investigations, and we have found that zone of inhibition was maximum for E. coli. Therefore, this MnO2 oblique BC can be used to control the E. coli bacteria in water, or the growth of the both bacteria can be there in comparison to this control. So therefore our material MnO2 oblique BC is good in this sense that it can also control the growth of bacteria, both positive and negative. Now other, we have prepared this iron oxide BC hybrid composite. Same study we have done, and but with the advantage that this is a magnetic composite. We can use it and we can separate it by applying the magnetic field. So this make advantages. Now same type of studies we have done. I'm just showing what we are doing in our department, and having, again, we can control the pneumonia. This pneumonia also, this picture shows, this table shows rather the effect of here we have these material more effective for S. aureus bacterial stains, positive. Now this is the other work we have carried out by using manganese ferrite hybrid nano composite we have prepared, and this scheme has been given over here, and we got it published in a very good journal of cleaner production, uh, having impact factor 9.3. Just for motivating the students, I'm just giving the information, and the preparatory mechanism is depicted over here. This is the method followed for the characterization. Again, no, again, but the material is having a different 0 point charge. It is 7.3. Again, we have characterized and found varied parameters. Now, this material was not so good as compared to the earlier one. It could absorb Q naught value we got is 10, 8, and 9. It means the absorption of the dye molecule reduced with increasing the temperature. Again, the it was again no, look at this. It was uh, good for SRS bacterial states. Now this is another work we have carried out. It is a mixed oxide, iron oxide and zirconium oxide, and we got it published in a Journal of Molecular this cleaner production. Again, a very good journal, and the scheme has been given over here. Again, the same work we are repeating, but this surface charge was different. It was now 8. It means it was better for negatively charged dye molecules or metal for the adsorption purpose. Now we have done just this is the work we already have published in Journal of Molecular Liquids. Now the cyclic use of these material have been carried out, and these are the cycles: 1 cycle, 2 cycle, 3, 4, 5, and 6, up to 6 cycle. The capability or the adsorption capacity definitely got reduced for both arsenic and methylene blue. Uh, this methylene blue was the target dye we have used, but it is having sufficient adsorption capacity. Therefore, the material can be used in cyclic way. This again. This is another work we have done with iron oxide, then tin oxide, BC hybrid composite, and it has been published in again good journal, Environmental Research. Impact factor of this is around 6.5. Now I'm just showing, not displaying. These are all the graphical like things. Yes. We have now advanced our research, and we have used Tulsi leaves for the composite formation, and this work has been again this is the Tulsi powder we have prepared, and this whole, and it is this iron oxide Tulsi nano composite, and this is again magnetic. You can just look at this. It is a magnetic. Therefore, it has been characterized. Now, adsorption studies has been taken, and thermodynamics have been studied. This is another work where we have used guava leaf, because guava leaf is having very good medicinal properties. Tulsi powder is having good adsorption as well as medicinal properties. Our purpose is just to combine both medicinal qualities of metal oxide or metal and the plant-based material, and we have got it published in again Journal of Cleaner Production. Yes, we have done. These are the XRD that indicates the peaks, different peaks, and here we have cementum. It indicates the growth of Look at this. This is a plant-based material, and in between these, we have gone these metal oxide, mixed metal oxide uh, nanoparticles, and these are the parameters we have studied. Again, we have delta G value 9.9, 10.7, and 11.7. Again, it is uh, endothermic reactions, and the feasibility of the adsorption is higher as compared to the previously used compounds. And delta H value is 17.7. Again, delta S value is 0.09, indicating the mechanism where hydrogen is replaced by the dye molecules or any pollutant molecules. Therefore, this delta S value is coming positive. Now, these are the things. Now, ultimate purpose of the whole topic was to get clean water, and we have no other solution but to provide green technology based on plant uh, so that it is sustainable for future generation, and the goal is to provide drinking water, safe drinking water. Thank you very much uh, to the organizers for inviting me to uh, present my work over here, and hope you might have enjoyed, although it was a research-based talk, not a normal one. Maybe some of the students they are unable to understand the research like things, but other people who are into research, they can understand the importance of uh, this nanotechnology for water treatment. Thank you very much for inviting me, Sister Eddie Joseph, Madam Lena Matthew, and other faculty members of the Department of Chemistry, BK College, and the sponsor and Dr. Roshni for kind words about my work. Thank you very much.